Hello everyone, I hope you all are well. My name is Abhishek and I currently work as a senior software engineer at Zomato. I have been part of the Zomato's family for the past 6 years and I've worked with multiple teams. Currently I am working with the site reliability team which deals with everything related to DevOps, whether it is CI/CD, observability, logging, alerting, monitoring, internal tools, everything. And today with me I have Somil and I'll let him introduce himself in some time. So let's dive in. So today we're going to discuss about us, who we are, our journey with MongoDB. We'll also explore some of the use cases and products which we have built on top of MongoDB, delving deep into two of these use cases. A little bit about us. So we are a group of multi-large tech ops businesses. By tech ops, we mean operations-intensive enterprises backed by robust technology. So first two up are Zomato and Blinkit. I believe Zomato and Blinkit needs no introduction here. So by the way, how many of you are regular Zomato users? Can I get some show of hands, please? That's fantastic to see so many hands. Yeah, so Zomato is one of the largest consumer tech companies in India. It is a technology platform which connects restaurant partners, delivery partners, as well as our customers, fulfilling their multiple needs. Customers use Zomato app to either order food online, pay via Zomato Pay, explore dining options, submit restaurant reviews, etc. Blinkit is our quick commerce venture, ensuring that whatever our customers need on a day-to-day basis is delivered to them within minutes at their doorstep. Next up is Hyperpure. Hyperpure is our procurement solution, supplying high-quality raw ingredients and kitchen supplies to our restaurant partners. Next up is Feeding India. Feeding India is our not-for-profit organization who aims to reduce hunger among the underserved communities in India. Till date, we have delivered over 140 million meals. Finally, we have Zomato Live, whose flagship event is Zomaland. I believe you must have heard about Zomaland. So it's a food and entertainment carnival held across various cities in India every year. So it features a wide range of culinary delights, a plethora of fun games, as well as a fantastic lineup of artists. Today, we're going to mostly focus on the food delivery business of Zomato and how MongoDB plays a pivotal role in powering it. So these are some staggering numbers from our most recent quarterly report. Over 17.5 million customers have placed orders with Zomato, with over 350,000 active delivery partners on the streets of India, picking up food from our restaurant partners and delivering to our customers. We are partnered with over 220,000 restaurants, all dedicated to serving our customers. So we have been leveraging MongoDB for quite some time now. Back in 2017, when we used to host our self-hosted replica clusters on AWS EC2 instances, there were a lot of pain points in managing those clusters. So we all are very much aware of the pain points and intricacies of managing self-hosted clusters. So as Zomato's business was expanding at a remarkable pace, we realized that it is prudent for us to migrate all our self-hosted clusters to a managed platform. And we integrated with Atlas. So as Zomato's business and portfolios kept on expanding, our use cases for NoSQL and MongoDB also kept on growing. Today, we have over 26 plus clusters of MongoDB with tiers from M10 to ranging to M200, which is our largest cluster. We have 3 to 7 members replica set with over 5 TB of data actually in our cluster, while rest is archived. Coming to the features of MongoDB, MongoDB boasts some invaluable functionalities which we really like. First up is index suggestions. So index suggestions help us to identify slow queries even before it reaches to our production environment. So we have a pre-prod environment in place. And as soon as a bad query reaches there, MongoDB alerts us that probably this query needs an index, and hence we are able to fix it. I must say MongoDB support is one of the best out there. I'm saying this in my personal capacity as well as my experience. So at Zomato, we have integrated with a lot of third-party cloud providers, and we have to interact with a lot of support executives on a day-to-day basis. But the kind of knowledge which MongoDB support has about its system, as well as the analysis which they provide on the issue at hand, truly stands out. We are able to solve our issues within no time. Next up is Profiler. Profiler helps us to identify slow queries real-time in production and fix them. Analytics node. So we use analytics node to copy or archive our data from production environment to a in-house data platform setup. So this is possible with analytics node because it provides a separate connection string, and our production traffic is uninterrupted, and no issues there with production traffic. Capped collections and TTLs have helped us to keep our data as well as costs under control. So we often don't need data which are older than 6 months or even a year, and we can either archive them or delete them. So with TTL, it is possible. Geospatial queries. So as Zomato is a business, there are a lot of location-related data. So we have had use cases where we need to locate a locality on the basis of the coordinate of the restaurant partner or the delivery partner and identify the locality. So these are some of the use cases and products which we have built on top of MongoDB. I'll be discussing some of these in the subsequent slides. So order tracking screen. I believe you all must have seen this screen at least once while placing an order. So this screen powers our live order status as well as the live location of the delivery partner. So the base of this system is rider's location, and guess where it is stored? It is in MongoDB. So we get a high influx of locations coming from around hundreds and thousands of riders across our country, and we ingest them into our system, and it is stored in MongoDB. After doing some processing, we forward it to our other microservices, and finally it powers this screen. Order assignment system. So this is one of the most complex and critical systems at Zomato. Here, to assign a best suitable rider for a particular order, we need a lot of metadata information related to order or restaurant partner, and all this information is stored in MongoDB. Now, this is possible because MongoDB provides us flexibility where we can add and remove properties as and when needed. So MongoDB helps us here. Order detail system. Once you place the order, you can see the items as well as the quantity of items of the order. So this is very crucial information for us because we need to relay this to our delivery partner, so there is no pickup issue. Again, this is stored in MongoDB. Delivery partner expected earning screen. So this is the screen which we show to our delivery partner once an order is assigned to him. Here you can see the expected earning section. So this is the earning which the rider will get on this order. So now to get this information or to compute this earning, there are a lot of factors which comes into play, like the location of the rider, the distance of the rider from the restaurant partner or the customer partner, or whether we have to apply search pay, or what is the carrier type of the rider, whether he is using an e-bike or an e-cycle or motorcycle. So all these factors come into place, and all these are stored in MongoDB. Once our assignment system picks this order, we get to compute this thing from this data, and finally, this expected earning thing come up. Featured restaurant system. So here you can see this, once you open Zomato app, this is the first thing you will be seeing. This is the set of featured restaurants. So our restaurant partners create campaigns for their targeted audiences on a specific time interval, whether it is dinner, lunch, or breakfast. And there are a lot of properties, again, coming into the picture. It is stored in MongoDB. So once our customer opens the Zomato app, on basis of its location as well as other properties, we find this set of restaurants and show us to our customers. Finally, we have delivery partner onboarding system. So we have to onboard a lot of riders on a regular basis, and there are a lot of information which we need to collect from them, such as name, address, their driving license, their carrier type, everything. And finally, we store them in MongoDB. So this is the high-level architecture of our one of the most critical system, which is delivery partner location system. Without delivery partner's location, there is no online ordering. So as you can see, there are hundreds and thousands of riders on the streets of India, continuously publishing a location at a very high rate. Now, we use AWS as a cloud provider, and we have a load balancer in place. Once this location gets ingested into a system, there is an MQTT broker cluster sitting behind the load balancer. So now, what is MQTT? Anyone knows about MQTT? Yes. Yeah. So MQTT is a message telemetry protocol built on publish-subscribe model for the Internet of Things. It is extremely lightweight, and it is very powerful. So once this system reaches into our broker cluster, there is a set of subscribers sitting behind the cluster in our backend application. So our backend application again processes this data and store it in our in-house memory database, in-memory database, which is Redis, and finally into a persistent storage, which is MongoDB. So now this information needs to be relayed to other services as well, and we use Kafka for asynchronous transmission. So now this system might look like very simple, but there are a lot of hundreds of microservices behind the system interacting with each other and exchanging data to finally power a lot of systems at Zomato. Again, why MongoDB? Flexible schema. We store information such as his location, his current speed, delivery partner's current speed, his locality and all. So we store it in MongoDB. TTL again, so we don't need riders' location which are older than 6 months or maybe a year, and we can freely delete them. geospatial queries as explained before. And finally, as this is a very high throughput system, like we get hundreds of thousands of requests per minute. So we needed a database which can handle this load without any issues, without compromising on the latency part. So again, MongoDB suited us here. So now, before jumping onto the screen, like I have one question for you all. Like, what is that one thing which engineer looks for while working in a software company? Any guesses? Bang on. So it's not about free food or whether work-life balance is there. It's the scale. So like any other consumer tech company, even Zomato has its peak day and it's New Year Eve for us, where our customers place the highest orders. And we get insane amount of traffic on that day. Now to handle this load, weeks of preparation goes into process. And our entire engineering team is at the Zomato's office on that New Year's Eve, just to make sure that there are no glitches into the system and our customers are able to place order without any issues. So here, as you will see, our normal peak day traffic on a Sunday peak is around 600K RPM. But to load test our system, just to make sure there are no issues, we did a load test of inserts of around 1.7 million RPM. That's pretty high. Even at that high latency, MongoDB was able to, high throughput, MongoDB was able to maintain its latency below 5 ms. That is pretty much. Also, if you notice, if you can see the date here, it's tested on 14th December, 6:30 p.m. IST. So we test it on a peak time only just to replicate the exact scenario which we'll be observing on that peak day during a New Year's Eve, and to make sure that there are no issues. We use M200 level cluster here. This is the highest or the greatest cluster. This is the CPU graph. Here we can see that the CPU is below 60%, even on the peak traffic. And this graph is of the latency graph, which is showing that the latency is below 5 ms. So this was all about the delivery partner location system. I hope you had some informative session around it. Now I'll invite Somil, who will be discussing about the chat backend system and how MongoDB plays a pivotal role in it. If you have any questions for me, probably we can discuss after this session, and I'll be happy to answer. Thank you.
Thanks, Abhishek, for introducing us to how we are using MongoDB at Zomato and giving us a high-level overview of delivery partner location system. I am Somil Kanbal. I am a software developer at Zomato. I've been here for almost 2 years. So I'll be talking about Chat SDK and how we are using MongoDB to power it. Chat SDK is the backbone of communication across various aspects of Zomato. We power customer support, ticketing support, customer delivery partner chat, and we have our own internal dashboard which agents use to reply to customers. So whenever a customer reaches out to support through in-app or whether via email, our Chat SDK is there to facilitate that conversation. Apart from that, customers and delivery partners can coordinate with each other. Whenever a delivery partner is assigned to an order, customers and delivery partners can talk to each other till the order is delivered. They can coordinate on various issues like helping finding addresses, etc. So now let's dive deep into how MongoDB powers our Chat SDK. The journey for an API begins when an API request is fired from the Chat SDK, which is integrated into customer devices or via admin dashboard. It lands on Akamai, which is our CDN WAF layer. From there, it goes to AWS load balancers, and then it reaches our backend application. We store and retrieve all the messages in MongoDB, as well as publish all the messages via MQTT for real-time communication. Similarly, we also store read events. So whenever someone reads a message, we get API calls. Again, we store all this data in MongoDB. And whenever every participant reads a message, we mark that message as read. Okay. So now let's answer the question why we are using MongoDB to power our Chat SDK. Since all this data, message data, read events data is non-relational, we were on the lookout for a NoSQL data store. Apart from this, we wanted a database which provides strong consistency under read and write heavy workloads. Okay. We did not want messages to go in an inconsistent state or messages disappearing from the chat. Basically, our product demands a database which offers strong consistency. Apart from this, Chat SDK supports a wide variety of message types, like emails, text messages, images, media, videos. All of these come with their own unique attributes. So MongoDB's document-oriented data store perfectly fits all these requirements. Apart from that, we have multiple query patterns, which can again only be satisfied by a document-oriented store. So we currently operate at a write throughput of 5500 and a read throughput of 7700. Okay. As Abhishek mentioned, we load test our clusters before New Year's. So we load tested at 3x RPM before last New Year's. Currently, we operate on an M50 cluster, but for this load testing, we provisioned a separate M60 cluster. MongoDB performed admirably well under this heavy workloads. It held CPU utilization under 12%. We at OneSupport, which basically owns all the Chat SDK, have been using MongoDB for almost 2 years. And we are in the process of migrating some of the features from other databases to MongoDB, and we are building new features on top of MongoDB. We have been using this MongoDB very comfortably. So yeah. So thanks for the attention. Also, we are always on the lookout for great talent. So if you are interested, you can reach out to me or Abhishek for referrals.
Thank you. Thank you.